Hey everyone, I am K.Harshith. Today I am gonna explain the what are the properties of magnetic field lines. First of all, basically, what is a magnetic field? Magnetic field is nothing but it's an area where we feel the magnetic effect or the magnetic effect I can say. Now, if you see, when I take a bar magnet and then sprinkle some iron fillings, they resemble this shape. They resemble a shape like this, which means that here there is magnetic field generated wherever we see the resembling of the iron fillings. There is magnetic field that is filled. Now we can feel here because we can see that they are resembling the shape. If this is not a magnet, if we take a normal iron bar, if I take normally this duster, the iron filling wouldn't form, but it is forming when you take a magnet, because magnet is providing magnetic field. And then now the magnetic field lines is nothing but these are the imaginary lines that represent, or they say that there is magnetic field. Now, properties of magnetic field lines. Now the figure itself which I have drew here, with the help of the figure only we can say that we can list out the magnetic field line, properties of magnetic fields. Now the first thing from the figure, what we can see that the field lines resemble in form of concentric circles. They resemble the shape of concentric circles. Next, now if I say, now this is the north pole. Geographically this is the north of the magnet and this is the south of the magnet. Let me say, if we see the magnetic field lines, they run from north to south. I will be discussing an activity, how we got from north to south. Now the magnetic field lines, they run from north pole to south pole outside the magnet. They run north to south outside the magnet, but if you see inside they run from south to north. I will be discussing an activity, as I said, run south to north inside the magnet. Now next, now iron fillings. If the number of loops, I can say these are loops, if the number of loops are more, can we say that even the magnetic strength is also more? If there are more loops, it says that there is more amount of magnetic field generated. So more number of magnetic loops or magnetic loops, more magnetic field, more magnetic field. Then we also know another property. The magnet is strong at poles and weak in the center or in the middle. Now you see, magnetic field lines are formed at the corners, at the poles, at the corners. They are not formed here, right, in the middle. They are formed at the corners, which means that the magnetic field or the magnet is stronger. It shows its strongness only at the poles. It doesn't show its strongness or it is a weak near the center of the magnet. So these are the 1 2 3 4 5 6 properties of magnetic field. Another thing we can notice from this figure is two magnetic field lines. Two magnetic field lines. Two magnetic field lines never intersect. Two magnetic field lines never intersect. Now if you see, can you see there is intersection? Now intersection is like this. This is the magnet. Okay, this is the magnet. Intersection means it should be like this, means at this point they are intersecting two magnetic field lines. But now in the figure, or really also, if we try to sprinkle the ion fillings, they doesn't form like this, they form like this. What happens if they intersect? They will not intersect, because if they intersect, then at the point of intersection, compass should show two directions. Now if now here, if you keep a compass, because there is magnetic field generated, if you keep here the compass, one deflection, it means it will show one direction. But here, like this, the magnetic field lines, this is one, this is one, this is one. Here one magnetic, two, so it should show two directions. Will the compass show two directions? It will have only one needle. How can it show two directions? So then at the point of intersection, compass should show two directions, which is not possible. So a compass, the magnetic field lines never intersect each other, because at the point of intersection the compass need to show two directions, which is not possible by the compass. So that's why the two magnetic field lines never intersect. Now as I said, I would be showing an activity, we will be discussing an activity. Now let me take a bar magnet. I am taking a bar magnet with a north pole and a south pole. I have taken a bar magnet with a north pole and a south pole. Now take a small compass. Such that north pole of the compass is facing the north pole of the magnet. The north pole of the compass is facing the north pole of the magnet. Now like poles repel, so it will be forming like this. It will be like this, south north, and again here there is north, so again deflection, south north. Sorry, this is the compass, right? So compass would be south north, then again deflection, south north, again deflection, south north, again here south, here north, and again now if you see north south, so it would be forming south and north, because south pole, here we are having south pole, right? South pole, the repel, so they form in this manner, south north. And then next, again it will be forming like this, north to south, so as you can see here, again south repel, so again north will come downside. So like this, outside, this is the direction of the magnetic flow, and again in this manner, so north to south. Inside you see south to north. So as I showed, it is north to south outside and south to north inside. This is the activity that says or that shows the direction of the magnetic field. That is from north to from in outside north to south, inside south to north. So once again, the properties of magnetic field lines: the magnetic field lines are concentric in circles, then they run from north to south outside, inside they run from south to north, and then if the number of poles increase in the magnetic field lines, then even the strength of the magnet would be increasing. Or if more number of loops, which means that the magnet is more stronger, and then the magnet is stronger at the poles, weaker in the middle, and then the two magnetic field lines never intersect, because at the point of intersection the compass need to show two directions, which is not possible by the compass. So these are the properties, and this is one note that we can draw, and then the activity to show the direction of the magnetic field. I hope you have understood what are the properties of magnetic field lines. Thank you.